Hello, I'm Alexandros, and I will be giving a brief presentation of our work, Learned Representation Guided Diffusion Models for Large Image Generation. We are interested in building generative models for large image domains, such as digital histopathology and remote sensing. Generative models in these domains can have widespread applications. For instance, in digital histopathology, they can be useful for education, as well as privacy and data sharing purposes. In general, we are aiming to build a specialized foundation model for large image domains, which we know can enable several downstream applications. One such application is data augmentation, which we showcase in this work. Training large-scale and high-quality diffusion generative models relies heavily on providing appropriate conditioning, for example text prompts in stable diffusion. However, in these domains, annotating all images is infeasible, as it usually requires utilizing expert annotations. As an example, we asked the pathologist to write a text caption for each of these patches, and figured out that annotating an entire dataset would take more than 40,000 hours of their valuable time. There are vast amounts of unlabeled data in these domains. Previous works have shown that self-supervised learning approaches can be successfully leveraged for tasks such as classification and segmentation, where again the pathologist's annotations are limited. Therefore, we propose using representations extracted from self-supervised learning methods in place of human annotations to train a diffusion model. Since these representations can be used to classify and segment these patches, we know that they encode the important textual and semantic information that we need to synthesize new images. We trained a latent diffusion model, conditioned on SSL representations, and we observed that the synthesized patches closely followed the appearance and semantics of the images from which the SSL embedding was extracted. This comparison is shown in the top and bottom rows of this figure. With that in mind, we can then perform augmentation by first extracting the SSL embeddings of the real patches in the dataset, and then synthesizing new variations to which we assign the same label as the source patch used. We augment the classification dataset and observe significant improvements when using our augmentation approach. Until now, we have been discussing the generation of patches, but in these domains we are also interested in generating the large images themselves, which can be up to 32,000 by 32,000 pixels in size. To this end, we introduce a large image synthesis algorithm that only uses the patch-based model. Given a reference large image, we first apply the SSL model on the image patches and get a grid of condition embeddings. Then, we use the SSL representation guided diffusion model to synthesize a new patch for each of these conditions, while also making sure that we do not introduce any artifacts at the patch edges. Following the same augmentation approach as before, we show that we can augment datasets with new large images to improve classification accuracy. It is important to note that our augmentation approach also works in out-of-distribution settings. Our large image generation algorithm requires a grid of condition embeddings as input, which we've already shown that we can obtain from a reference real image. We also show how we can generate large images from any modality by training auxiliary models that map conditions, such as text or class labels, to the grid of SSL embeddings used as input. Using the SSL embeddings as an intermediary between text captions and large images, we are the first to perform text-to-large image synthesis for histopathology images. This approach also applies to large remote sensing images. So in conclusion, we introduced a method to train large image diffusion models without expert labels, we proposed an algorithm to synthesize large images using only a patch-based model, and we showcased the first text-to-large image generation for histopathology and remote sensing. Come see us at our poster on Wednesday at 5 p.m.